Ah!
That made me uncomfortable.
Oh boy.
Hey y'all, how you doing?
You got Subway? I got Subway.
Oh, lucky.
Lord.
It's about to smell your place up. Just heads up. It's not gonna smell. It
No,
might
amazing.
smell bad to other people. But
This lab got long. I knew it would. So, Ozzy, come. Come on, Ozzy. Come. Come here. Come here. Come on.
Why'd you have to pinch all of
What do
these?
you get?
All right.
What do you get?
I got ham. I usually
Hi, Ozzy.
get Subway 1, 2, then
Say
have
hi, hi.
So I got white American,
Yes, I know.
lettuce,
Go.
black
Good.
olives, onions, green peppers, lots of honey mustard, and lots of sweet onions.
All right. All right. So we've got.
No way. That's exactly what I get when I go there.
No.
There's no way. Seriously?
Yep. So on.
Okay, we got 3 people online, and we're not going to keep them waiting. So lab ran over a little bit. Some people are going to be coming into class a little late, but that's because they're trying to finish up. If you didn't get your lab completed or didn't get all your data, it's online in Teacher Ease. So those of you who are online, go into Teacher Ease, click on the lab assignment. There's a link to a video with all the data, all the steps, everything nailed out. I did rearrange one step for the sake of making the video and time constraint, but it's the same data, basically. Yo. All right, so you guys about done? Okay, they're still working. Oh well. So we're gonna go ahead and I see you. I know. We're gonna we're gonna go ahead and start with it. We've got 3 online and most of y'all over here. I've got a slideshow that should help make it a little easier for those of you at home to follow along. Let me get it open because I was over there dealing with them. Has everybody had a good week? Yeah? No, Kai says no. Oh, Harvey. Not so much. Oh. I heard you had an interesting couple of days, so I understand that gets rough.
I had to be up at my grandparents' house, so.
That's what I've heard, yeah. That's a lot. It's a lot of responsibility. Yeah. Okay, so I'm gonna put my screen share on. And there we go. All right, this should be helpful for you guys to follow along. All right, so Cole, if you're not over here, then sit put. All right, so we're gonna start by looking over real quick, reminding everybody what we're doing, in what order we're doing it, right? All right, so we just finished up our first chapter in the book, which was a long one. They're not all going to be like that. Some of them are going to be just a section or 2 sections, which will not be so long. I know this one was long, but we're getting this out of the way so we can move into nitty-gritty stuff. And we're trying to keep aligned with the juniors class as much as we can, right? So we went into what is chemistry. And as for RICO, nobody won RICO because nobody gave me a RICO. So remember that on your homework sheet, if you want to, you can always color that RICO on the back according to whatever the theme is and send it to me or show it to me, and I'll pick one I like and you get candy. Thrilling. It's something, right? So who read the weekly email? Who did? Oh my gosh, all of you. That's really good.
I have a question.
Yes.
So like for Rico, because sometimes it says that on the homework keep in binder, do we then turn the homework?
You can show him to me or send me a picture, or like if I find out people have done it, I'll say, everybody put your homework face down and show me your RICO so that I can pick, But hey Cole, before you sit, can you do one thing? Can you go remind them that Daddy's working for another half hour before lunch break so they can keep their volume down? Thank you. All right, so good. You read your email. That's excellent. How many of you, wait, who's lab captain? You're a lab captain, you're a lab captain, you're a lab captain, and is Cole the lab captain? Okay, so you that went into your forum and said, one of you did. You did. Jack went and said, hi, I'm Jack. That's good. Michael responded to, Sydney had a question and Michael responded to it. All right, so remember that everybody needs to go over to their lab forum and make sure you introduce yourself so everybody knows what your user ID is, especially if it's not your name.
And I asked if what their usernames was so I could tag them.
Right. Good to tag people, because the goal here is for you all to have a place to share data. This week, the way you're going to get your data, if you didn't finish, is go into Teacher Ease, click on the lab assignment. There's a link to YouTube. It goes right to our channel. It's this lab filmed with all of the time, filmed for time constraints. So all of the moving back and forth of the triple beam balance, I like made it fast forward. So it's like, it goes really fast. And I chopped one part of it, so it's a little different, but you get the same basic data. My data numbers in the lab may not be the same as your data numbers, but if you didn't get a part of it, you can pick up where I left off. I mean, you can pick up from my lab wherever you left off, okay? So you're gonna wanna have this lab completed in your binder because it's got important information on how to move the solids and the liquids around, Oh, Cole has an apple and Ozzy just wants apple. No, you don't get apple. He loves apples. All right, so in the weekly email, I set up the forums, told everybody where they were. I'm just going over this to make sure everybody knows. Also, if you're absent or cyber for now or cyber in general, be sure you send any work to me in a PDF. Now, what I'll do when I get it from you, as soon as I'm on my computer and I get that email from you, I'll go ahead and I'll download it and I'll put it in a file of things that I need to grade. And I'll just write you back and say thank you so that you know I got it. Once I grade it, it will get returned to you. But you may not see, I may not send it back immediately because it's going in the file of things to be graded. And once I grade them, then I'll send them back, all right? So every week you're getting the class video uploaded. So you'll get that in your weekly email. And everybody, if you go to the Class Connect through the website, gives you our unlisted link. No. So all my grading was complete as of this morning. Now, remember that tests close at what time?
8 a.m.
8 a.m. So last week's test closed at 8 a.m. So if you weren't done by 8 a.m. today, it didn't get in there. So if you are missing a test, I will be responding to you and say, this is missing, and I'll tell you whatever the deal is. Like some people were missing a test because they had some emergency, or somebody had, like, we had 2 or 3 family emergencies this week, all at one time. So always let me know if you have a problem. And then for next, where are you going? I don't know. You might want to go out. Can you open the door? I think the guy's gone now. So brownie points. I don't think we discussed these too much. A little bit. But I'm a terrible typist. So if you see something wrong and you point it out, you can send it in an email. You can put it in the, it's locked because
I opened it, yeah.
I put it in, you can put it in an email, you can put it in the forum, whatever. But if you catch something that I've done wrong, spelled wrong, you can let me know, and you get a brownie point for your class. When your class gets 25, I make brownies. If you're cyber and you win a Rico or brownies or whatever, I'll ship them out when I do lab boxes. All right, so let's look at our notes for this week, okay? So you guys discussed 3 big topics. You know, what's chemistry, describing matter, and how matter's classified. And your homework was probably not your favorite homework ever, unless you're a numbers person. Who's a numbers person?
I hate
Okay. Alex is a numbers person. Yeah. Look at, Cole. Can you get Abby's binder? She left it over there. Because now you don't have to climb over Ethan and Cole, which doesn't sound like fun. All right, so the reason that I did, Kai's laughing at the idea of Abby climbing over Ethan and Cole. So,
Where is it?
In my room.
Oh, it's in there.
okay,
It's on the bar.
on the bar. Abby was sitting at the bar before class. All right, Abby. Okay, so the reason I made sure that your homework had so much math is to get that business out of the way. Once we're sure you guys have it, you understand it, you know how to do it, we're moving on, right? We'll use it again and again this year through labs, but I wanted to make sure that it was covered pretty thoroughly. All right, so was there, let me look at your chapter real quick and see if there was anything that you guys, did you guys have a question about anything? Was there anything that you read that you were all, I'm not so sure about?
Everything an answer?
Is everything an answer? Sometimes, sometimes everything is an answer.
Thank you.
So how about we go over some of these section review questions that I'll just ask, and then what we'll do is we'll go over the answers to the homework. So going over some section review questions. So after section 1, which is the whole what is chemistry, you got a question that says, name 3 natural chemicals and 3 artificial chemicals that are part of your daily life. Does anybody have a thought on maybe 3 natural? Yeah, you want to go with 1 natural? Okay, yes?
Stomach acid.
Okay, stomach acid, which is hydrochloric,
Water.
Water, okay, there you go. All right, yes.
Oxygen.
Oxygen, all right. Okay, so we've got 3, hydrosulfuric, yeah, can't speak today, stomach acid, water, hydrosulfuric acid, or hydrochloric acid, all these acids, yes. Okay, these are all things that you find commonly, right? All right, what's something that is maybe they're referring to it as an artificial chemical? Yeah.
Plastic.
Okay, plastics, that's a good one, all right? That's a great one right here. And again, Alex?
Gasoline.
Gasoline, okay. Gasoline is purified. Yep, okay,
Paint.
Paint, okay, there you go,
I think this is a chemical because it's what my grandma refers to as a chemical. Bleach.
Absolutely, yep.
Except they don't bleed.
Yep, bleach is a chemical. All right, so then tell me something that's part of your morning routine. And you guys online can answer. Tell me something that's part of your morning routine that involves a chemical.
Brushing my teeth.
Brushing your teeth. What do you brush them with?
Fluoride.
Fluoride, okay.
Shaving cream.
Shaving cream. Oh yeah, Michael needs shaving cream and more.
Okay.
I doubt you.
I
She
have
says,
more hairs on
okay.
my chin than you have on your entire face.
This is good. This is fun.
All the people with masks are like, I have a beard.
Okay, sure. Okay, all right, that's a good one. And then also what you're eating, whatever you're eating for breakfast. That apple is full of chemicals. That's a good one too. Did I put that in your first video? I can't remember. somewhere there is a fabulous list of all the chemicals in an apple. And it looks like something that, came out of a scary anti-pharmaceutical documentary. It really
nowadays,
does.
There's a lot more chemicals in your
Yeah, it's
apple.
true. But I mean, it's like, oh my goodness, what are all these things? Have you ever read the back of your shampoo? Right? Okay. But some of these things, like it'll say very often,
Oh, what my Dr. Pepper says.
very often it'll say citric acid.
Yeah.
Okay. Well, citric acid is in lemons and pretty much all
And
fruit.
it's phosphoric acid.
That's what makes-
Phosphoric acid, uh-huh.
That's what makes
that.
lemon sour.
Yep, yep. And then sometimes you'll see things that say acetic acid, that's just vinegar, so, and remember last year, those of you who were last year, we talked about this study done, but was it the European Chemical Association or something? And they put out a survey and they asked people who would you like to live in a world without chemicals? And what was it? Does anybody remember the percentage?
67 or something.
I think it was more than half of the people replied back and said, yes, they would love to live in a world without chemicals. And it's like,
You can't.
Right.
You
So you want to live in a vacuum.
yeah,
I mean, you
it's
don't want to.
scientifically illiterate, I mean, at its best.
But there's a
So,
difference between, like, harmful
yes,
chemicals
Shannon.
When you think of chemicals, though, I'm sure they're thinking of like the bad chemicals.
Uh-huh.
Yeah, everyone
Guys,
thinks of the bad chemicals.
pull. It
The
picks up everything.
pesticides.
Yeah, that's what they're thinking, but it makes you wonder if they've really given much thought to all the other chemicals that are around them every day. So let's see, somebody give me an example of a solid. That's easy. Anything is a solid. Okay, the table, there we go. And the goldfish and the liquid. There you go.
Water.
All right, yeah, and then, gas. So it worked out great in the juniors because I had ice in my turbis at the time. It had not melted. So I was like, look, here's our solid, here's our liquid. And Eleanor, who wears glasses, gave us a great example of our gas because when we exhale, right, there is water vapor in the air we exhale from our lungs. And that water vapor was coming out of the top of her mask, hitting her glasses, cooling and condensing, and she was getting fog every time she breathed out. And I was like, Eleanor, look at that. You giving us the example of water as a gas. We can't see it in between, but when it hits your glasses, we can see it. All right, so then somebody tell me about particle motion and the 3 states of matter. Who can tell me about that? Who has an idea of
Well,
about?
as a solid, the particles barely move at all.
Okay. Mm-hmm.
And as a gas, they move around a bunch and super quickly.
Mm-hmm.
And then as a liquid, they stay almost together, but still move around.
There you go. Yeah. You kind of want to think of it like, as a solid, they're kind of locked. As a liquid, they move around each other a lot. But as a gas, they tend to float around and bonk into each other.
And escape.
Uh-huh.
I was watching a car race and they were going like super duper fast, like upwards of 210 or like close to 210. And you could actually like see the air because they're not like these cars that we drive. They're like these super aerodynamic rocket ships on wheels.
Yep.
And then you can see the air kind of like darting off of
Yes.
it and like them making the trail so you could kind of see.
You can see that planes and helicopters sometimes.
Mm-hmm. Yeah, sometimes you can see the motion of the gas when it gets more dense, and as it gets dense because it's being pushed or parted or separated, you can see like the waves. That's always interesting. And then sometimes you can see the effects of it. Like there are those big, I wish I had one. I'm gonna get one day. It looks like a bucket, and you pull the back of it. There's a diaphragm, and you pull the back of it, and it forces the air in it to shoot across the room. But you can shoot things out of them, and you can also, like somebody way across the room can feel it. Yeah, like smoke rings. But like if you were way over there, Michael, and I did it, like you'd get the burst of air way over there. It's kind of fun. All right, so then tell me the difference between physical and chemical changes. How do you know what's a physical characteristic and what's a chemical characteristic and about their changes?
So a physical change would be something like ice melting.
Mm-hmm.
So you're changing its physical state, but the chemical compound it's made out of and its chemical substances don't change.
Right.
So, like a physical change would be me moving something.
Right.
But when I moved it, the table's still table and the book's still book.
Right. Mm-hmm.
And a chemical change is, you move you move something or you create that kind of reaction.
Yeah. Change
And
it
then-
beyond
It changes beyond what it's already made out of.
Right, it changes its characteristics entirely. So if you have
It's
water
non-reversible.
and you melt water, it's still water. Like its molecular form is still H2O, right? That's not going to change. But if you include water as part of the photosynthesis reaction, some of it remains water, but not all of it remains water. Some of it gets used in part of the reaction. So that's a good example. Okay, tell me, did you have any physical or chemical changes in your lab today?
Yes.
Yes. What do we have?
There was the copper making the fire go green.
Mm-hmm.
And that was a chemical change, and then the physical change was the copper turning into liquid.
Glowing.
Dripping.
Yep, the copper did melt in some cases. And when it melted, that was definitely a physical change.
Yeah.
The fact that it charred was a chemical change. And shush. And the fact that the bottom of your evaporating dish charred. Now, it talks in your lab about the reaction that caused the soot on the bottom of the evaporating dish. And it talks about methane. In our case, it was propane, but the reaction is pretty much the same thing. You get the same effect. So what you ended up with was soot because you had a chemical reaction occurring, and it was definitely kicked on by the flame. Yes.
So I have a question.
Yeah.
It's like chemical and physical. It is like when you take like a clump of dirt
Mm-hmm.
and you throw it into like a river or something,
Right.
and that kind of like disperses.
Mm-hmm.
Would that be like a physical or? a
Yeah, that's still
chemical change?
physical. Mm-hmm. Because basically what you're doing then is you're taking a mixture, which is the dirt, and forming it into a solution by mixing it in the solvent, which is the water. So yeah, and you could still separate it if you could find all of it. If you were to put it in a bin that swished around, you could still find all the pieces. But sometimes those little pieces will get sucked away and compressed down and go through enough heat that they'll break down, and the actual mineral components of the pieces of rock in the soil would join with other minerals and form different chemical rocks, and that would be your chemical change.
That would be what, sedimentary?
Well, you would be talking about it first being sedimentary and then being igneous, but way, way down under the surface of the earth when it gets super duper hot.
That would be minimal.
Yeah, but you get, you have chemical rocks, and then you have like salt, and then you have chemical reactions that cause particular rocks. That more often you get the chemical rock, because it's still physical. It gets complicated. We get back to earth science. We'll hit on that one. I'm throwing the dog for and stealing my shoes. So then, let's see. So,
Sorry.
why do neither liquids or gases have permanent shapes?
Because they're not bound tight enough to
Right.
stop them from
Right.
spreading.
Mhm.
Molecules aren't.
The molecules and the particles within it are pretty tight together, right? They're not as free flowing as they are in liquids or gases. So we say a solid maintains its volume and maintains its shape, right? And that has to do with what Michael was saying about molecular structure, and then the molecules and the particles within it not moving too much. They're vibrating, right? But they're not bumping all around. So there's your solids. In a liquid, you've got the volume is going to stay the same under constant pressure, right? But the shape will change. If I pour my water here from my turbis into a coffee mug that was big enough to hold it, it would change shape, but the volume is going to stay the same, right? And that's because when you get to the molecular structure of the liquid, the particles within it are moving around and they're touching each other and they're slipping past each other, right? But they're not bouncing about freely, and they're not as locked together. And then with a gas, you're going to have a substance that doesn't maintain the volume necessarily and doesn't maintain the shape. It'll take the shape of whatever container it's in, and volume-wise, it'll spread out as much as it can. It'll take up the comfortable space for that gas. So if you blow up a balloon, okay, you put that gas under pressure, right? Now that gas in there is taking the shape of the balloon because that's where you're forcing it to go. But the more you blow, the harder it gets to fill, right? So the harder it gets to fill because there's more and more and more pressure. But if you pop the balloon, you equalize the pressure, where does the gas go?
Everywhere.
Yeah, it doesn't stay like this, right? It just spreads back out and equalizes everywhere. And that's because those molecules can bounce around more freely. So we talked about states of matter, types of matter, and we talked about describing matter. Somebody tell me the difference between mass and weight again. We talked about it yeah, mass and weight again. We talked about it last week. Go ahead, Ethan.
Mass is a constant, and no matter like what kind of gravity or
Right.
you'll always say the same. Well, weight is kind of like
Depends on how much gravity there is.
Weight's relative.
Yeah, weight is the force of gravity on a mass, right? And then mass is how much stuff, how much matter, right?
Mhm.
So your book even had a whole paragraph that said mass is not weight. And we've been over that. So we talked about SI units, which we also talked about last week too. We wanted to make sure that we've covered them pretty thoroughly because they are not familiar to us. We don't use them every day. If somebody said, go get a 30-centimeter piece of yarn, most of us were not gonna estimate that, like you could estimate a 12-inch piece of yarn, right? But the more you use them, the more familiar you get with them, and they certainly are easier when it comes to the math, which was the homework, which we're gonna go over. All right, so we talked about density too. And there's a good figure on page 17 of your book. I like this. They made a rainbow graduated cylinder, right? And that's kind of cool. But you can tell that each of these items have a different density. So at the bottom, they've got glycerol, okay? And then they've got this little bit of rubber. I don't know what that's about. And then our water, all right? And then oil always is on the water, right? Oil floats on the water. You know that. You've all seen it. And last year, we did one where we had to get the oil out of the water. Remember, we had like rocks and oil and a pump.
That was weird.
Yeah, that was hard. It was really hard. And then ethanol. What is ethanol?
Gas.
Fuel alcohol.
It's an alcohol. It's an alcohol, so that's going to make it less dense. Now, has anybody ever poured alcohol onto water to see what it does? Okay, I think we'll have a minute at the end, and I'm going to do that for you, but I didn't want to get it out in case we were absolutely sure. And put the on here, you can tell. Kai looks so comfortable. She's wrapped in a blankie.
I just got home. I'm so comfy.
I like it. I like it.
So tired.
I like it. I like you to be comfy. Comfy is good. All right, so we talked about pure substances, and we talked about this a little bit at the end of last year too, for those of you who are here. So can somebody tell me the difference between a pure substance and a mixture? Give me an example of a pure substance and a mixture, or a pure substance and maybe a solution, to be more specific. Nobody wants to
Pure
go?
substance is just one molecule, element, chemical, whatever.
Mhm.
Whereas a solution is a combination of that.
Right. So your pure substance can be just one element. Like oxygen, for example, doesn't float around on its own, just one atom. They tend to be linked together for stability, which we'll get into. So when you've got your one oxygen molecule floating around, it's a pure substance, even though it's going to have more than one atom. But they happen to be the same atoms. Water has different atoms, right? It's got hydrogen and oxygen in it. And it's a pure substance if you get pure distilled water as opposed to tap water, which has all kinds of stuff in it. This is water that came through my fridge, so it's filtered, but it's probably a solution. It's probably got some other stuff in it. It's probably not straight up pure.
Water thing that we did.
Yeah, yeah. So your molecules that make up solutions or mixtures can be, you can have, for example, one molecule from salt. That's what we had today, right? NaCl, okay, sodium chloride. And you can dissolve that in water and make a solution. You could also take that same, and that's still gonna, the sodium chloride is not breaking up in there. It's still gonna be the same. You just dissolve the crystalline structure, right? You could also mix the salt and pepper in a bowl and stir it up. And now you have a mixture. The mixtures and solutions can be separated. How do you separate a solution? Like, what's a great way to get salt out of water?
Evaporation.
Evaporation, right? Okay, you're gonna get rid of the solvent, which in that case is the water. It's just gonna leave the solute behind, which is your salt. So that's a good way to get a solution separated. Next week, we're gonna separate mixtures using vacuum filtration, which should be really fun. So I've got hand pumps for you guys, because sometimes they the vacuum filtration hookup is such that like you plug it into a lab sink and you use the flow of the water to create the suction. That gets a little crazy. So we've got hand pumps, they have gauges on them, but when you squeeze it, it's gonna create a vacuum.
It's like when they take your blood pressure. And
Kind of, it's more of a handle like that, like the kind you'd use, like you know those little grabby claws?
That's our whole-
It's like that. It should be really neat. And for those people that aren't here, I'm gonna film that because that's too complicated to be one that I could send home. All right, so it talks about mixtures varying in properties, and there are two main types of mixtures. You've got homogeneous and heterogeneous. Does somebody want to volunteer the difference or give an example? Yeah. Do you want to go, Alex?
Yeah. Homogeneous is the thing, everything's distributed equally.
Right. Okay. And do you want to do heterogeneous?
Okay, well by that, I'm thinking that, whatever that word is.
Yeah, heterogeneous. Uh-huh.
That one.
Okay.
I'm thinking that it's all, like, it's only one?
Different. Okay, so
Okay.
basically, when you look at those words, okay, this is when we get back into our Greek and Latin roots. We've talked about this before too in the past in other classes, but it's really good to learn some of these prefixes and suffixes and root words because it helps you understand a word without even having to look it up or get a definition. So genus has to do with state of, all right? And then homo means same, right? Hetero means different. So when you have a heterogeneous mixture, if I took, okay, so here's a great example. Cole's got goldfish. Toss me a goldfish, please. Cole's got goldfish here. All right, when they made the dough for this little, oh, he's smiling. He's got the little happy face. There he is. Stack the smiles back. But when they made this dough, it was pretty homogeneous. There's no bumps or lumps or like bits of pepper or
Imperfections.
chunks of cheese, right? Yeah, it was pretty well mixed together, right? All right, so we ended up with this homogeneous mixture of dough, and we made this goldfish, and he's super cute, right? Oh yeah. Now, if we were to take this little container of goldfish and toss some pretzels in it, now we've got something very heterogeneous, right? The particles are all different. So when you talk about, you gave an example about like a stream in water. Okay, so if you get a dirt clod, dog. If you get a dirt clod, that's Jackie, I think. You're gonna have that's gonna be a heterogeneous mixture. It's gonna have sand, organic matter. That was not that high. That was me. But anyway, you're gonna have a heterogeneous mixture in the dirt. Come here, come. And then if you have the creek water, it's probably gonna be a pretty homogeneous solution. And it'll be a solution, it'll be a mixture of water, whatever the mineral. Well, if you just took that
He took advantage of it. His window was opportunity.
Hey, that's a win. Okay. Yeah, that was pretty amazing. Good job. All right.
Boy.
Good job, buddy. All right. So then let's have a look at the homework. So now what we want to do is, now some of you probably realized it's really easy to go online or use your phone and you'll get a little converter, right? And it'll convert these for you. But we want to know how to do it ourselves too.
We
So
did half and half.
yeah, so we're gonna go over these, and then what we'll do is, I've got a few other examples, we'll toss them up on the board, and we'll see if we can do them without using a converter program. So your first one in your homework said convert each of the following quantities into the required unit, and you started with 12.75 millimeters into kilometers. Would anybody like to give us the answer they got for that? Jack, what'd you get?
Millimeters?
Mhm.
We got 0.000001275.
Okay, what'd you get?
I thought that said megameters.
Oh, that's a good one.
It is
wait.
capitalized.
Oh, it is. Wait a minute. But you know what else? They were also capitalizing liter, which is weird.
Although the
It could be megameter. Yeah, you're right.
Megameters
You're right.
wasn't even in the
Yeah.
book.
It wasn't in the
it
book.
wasn't in the
So
book, but it came up later
Yeah.
on as well.
you're right. So sometimes,
Megameters, micrometers, and nanometers.
right, so micrometers is actually, they use a different
symbol.
symbol. It's a little,
Yeah.
it's
Yeah,
a
it's like
mu.
you with a tail.
It's a mu. It's a Greek M. So instead of looking like this, it looks like that kind of, right? Sort of. I'm not good at drawing it, but I did find it on the computer. You can find it on the computer. It's in the symbols, right? So that's a good question. If it's millimeters and we're converting millimeters to kilometers, does your book have a thing that says how they've done them? I may have totally missed it if it did, because I was going from the study guide. Let's see. Well, anyway, if you're going millimeters to kilometers, it should be 12,750. Okay? Does everybody have that? 12,750. And I believe they are using that as millimeters because there should be an answer guide here, but let me double check. Good question.
If it was millimeters to kilometers, then would it be 12,750?
Well, yeah, so hang on, you're right. Hang on, wait a minute. It's entirely possible.
So.
You don't make it a brownie point. Hold up. Let me look. Where is it? Shows up in here. Okay, let me get back to you on it because let me put another mark because I need to. Hey guys, shush, Cole. One of these 2 or 3 places. Everything's in different places. All right, whoop, I almost dropped that on your foot. Hold up. Let me double check it. All right, so now let's look at 277 centimeters to meters. What'd you get?
2.77.
There you go, 2.77 meters. Excellent. All right. Now, here's my answers in the back here, so let me see. Here we go. Yeah, 12,750 is what it's saying for A. So we'll check on that. All right, thank you. All right. How about 30,560 meters squared to hectares? What do we get?
3.056.
3.05. Whoop. Where did my answer go? My answer's not here. So my PowerPoint just failed me. So yes, 3.056 hectares should be your answer. I just popped up the answer for the next one. So 81.9 centimeters squared to square meters is 0.0081. That should say 819, not 818. I typed that wrong. Yep. Okay. Yep. Point. So it's 0.00818.
But it said over here on the left,
819.
thing you gave us.
819. Yes,
when
sorry.
it's centimeters,
Click
the
on.
decimal moves twice that
Mhm.
way.
So we'll practice them up here.
Just square
So we'll be sure we get them.
They both square them. So it doesn't matter.
Yeah, that's the same.
So
All
why
right,
did you
so
move
then-
four
Yeah, why does it
decimals
move
instead of
squares?
Wait a minute. I'm making sure I didn't.
Well, I know, but they're both squares, so the
0.00819.
conversion should be the
Take
same.
your room.
Yeah,
The
why do you
square's
have
the
like a
same. That
wet
doesn't
bar?
change anything.
Exactly.
Why do you have like a wet top?
Just
So centimeters to meters here. Hold up.
slightly.
I was gonna pull this up after we went over these.
You're drinking water.
So remember we have, let me make sure my whole screen is on here. Okay, we had King, Henry, right?
Yeah.
What is it?
Unusually bad.
Whoever's died.
Died
unusually
drinking coffee at the time. So
Okay, right, these are the big ones. What was over here?
Kilo.
What was over there?
Mega.
Mega.
Right,
Yeah, me and Mary.
and then what was over here?
The weird.
The weird one?
The weird one and
Micro.
Micro, right? So there's another M here and there's another M here. These are your big ones, right? So this is your unit in the middle and that's gonna be centimeters,
Oh,
whatever,
it's a-
whatever. Right?
All right, it'll also be like nanometers, I believe.
Right, there's nano and it keeps going.
Nano's not.
There's smaller ones and whatever else. Okay, so this though right here, these are the main ones. These other ones aren't gonna get used too often unless you get into like super uber chemistry labs. where you're
How
doing-
many molecules
Possibly.
in 1 centimeter?
Yeah, not gonna do it around. All right, so what did the question say? Okay, so you have 81.9 centimeters, right?
Squared.
81.9. Yeah, centimeters squared. Well, this, as long as you keep this unit the
Yeah, I
same,
know.
all right?
Just-
So if we're here, right?
Yeah.
And we're trying to go to
Square meters.
meters,
Yeah, so you're just going down
which
2.
is
2, so it'd be
kinda
0.8.
up here. So we start it here, right? It's gonna be here. We're going 1 and 2, right? So
It's
you
0.819.
have 0, 0.
There's
Hold
no
up, hold up.
extra
No, you are right. So why is that wrong in the book?
It's what?
I got the right answer.
No, you're correct. You're correct. But sometimes there's a book thing that
Do we
is.
get double the brownie points if the book's wrong?
Yeah, because when I put them in my slideshow, I didn't work them at that point. I just went through and put the
I got
answers
the right
down.
one in paper.
But that's correct. So that's not right. So this one here, that's 2 for you guys today.
We should get double the brownie points.
Yes, for the book being wrong.
Yeah,
It's got
it's gonna happen sometimes. Let me mark it in my book. Good thing you caught it.
Mom, it says, listen,
Wait,
Google does the same thing too.
Yeah,
Yeah.
they're both square.
Square centimeter.
A square.
0, 0?
Well,
Why
Google
would
says
that
it's
change?
Well,
Wait a
If
minute.
they're both squares, then why would it change?
I shouldn't.
if we get Google wrong.
That's a good one.
Google's wrong.
It says formula, divide the area by.
Right. 10,000. Oh, because it's double. Square. That's what I was thinking about. Because it's double, because it's square.
But they're both
So-
squares, so I didn't think there would be a difference in conversion.
No, there's a difference in conversion.
Because it's square. That's right.
But it's square meters and square centimeters.
Right.
Yes,
But it's
so you have to
still
convert it twice.
twice.
Right. Okay.
So
Oh,
that's
yeah,
what
yeah.
that is. So the book's fine. I'm just,
Because it's the.
I'm not awake yet, is my
Started
problem.
tripping.
And it's
There's
numbers.
1,000
Better than.
millimeters this way, there's 1,000 millimeters this way.
Right.
1,000
It's
each direction.
each direction is correct. So,
And 1,000
My
this
brain
way,
was not
but
turned on.
this way, right?
okay. So back to 300 kilometers to megameters. Who's got that one?
My confidence is shaken.
Now I'm gonna go back to hectares. There we go. Okay, 300. We have 300? Okay, good, good, good. All right. Convert each of the following quantities to the required unit. What do we have for 0.62 kilometers to meters? 620, good. All right, how about 3,857 grams to milligrams?
I got 300.
3857.
Yeah.
Yeah.
3 zeros at the end.
3 million.
Yeah.
875,000. Is that what we got?
Yeah.
Okay, there we go.
57.
How many zeros at the end? All right, there we go. Okay, then we have 0.0036 milliliters to microliters.
I got 3.6.
Okay, there you go. 3.6, and that's the weird looking microliter one that I'm terrible at drawing, but yeah, the sticky thing is the mu. It's this
Mu.
in the front. It's actually an M, but it's not.
It
M.
looks like a
It's-
weird.
Oh, it's
Right,
upside
it's like
down. It's an M where one side's longer than the other.
It's like,
It's
remember,
an H upside down. A
Kind
lowercase
of.
H upside down.
remember we had the lambda
It's like a
last
P
year
that I
and a
think
couple
got
of other ones.
never
They'll show up every so often.
Or it's like
Or
a
a U. something.
a
That's
lowercase
different. It's
p
or weird.
crossed
It's
with a U.
Sure. All right. So how about 0.342 metric tons to kilograms?
I get drunk upside
Starts off
down.
good and then goes down and then.
Anybody have that one?
Oh, which one?
3.42 kilograms. Do we have that?
340.
1 metric ton is 1,000
Oh, yeah,
kilograms.
342.
342?
3.42, because 1 metric ton is 1,000 kilograms. Okay. How about 68.71 kiloliters
I
to
got 300.
liters?
That's what I got.
Yeah.
342 for D?
No,
Because it
I
moves down
didn't get
too.
that at all.
Wait, I may have written it wrong.
1 metric ton is 1,000
Nope.
kilograms.
You're right, I wrote that one wrong. That's wrong. Okay, that's 3 today. 3 brownie points. See, I cannot type
Yeah,
that
me
many
neither.
things.
How many brownie points?
D is 342. You're at 3 brownie points. That's the book. I just
17
literally
more brownie
typed it
points.
wrong.
22.
Yep, it happens. I typed wrong.
25?
I think so.
I was 20.
That's a classic example of my typos are bad. All right, 68.71 kiloliters to liters. What do we get? 68,710 liters. Now, for whatever reason, they're capitalizing the L for liters. That is not always the case.
I think they did it so you don't confuse it with the volume.
They do, exactly. They do that because of the one thing that I usually don't capitalize that one.
Word of advice.
No, I
don't
think
have
you're right
bad
about
handwriting.
the M for the megameter is for that, for them being weird. Yeah, so that M is definitely the megameter M. All right, so then 856 milligrams to kilograms. 0.000856 kilograms. You got it, good. All right, so 1,210,000 micrograms to kilograms.
0.00121.
0.00121 kilograms. Good. All right, now we're getting better. 6,598 microliters to cubic centimeters. 1 milliliter is 1 centimeter cubed. Oh boy.
I highlighted that and.
Highlighted
Yeah.
too.
Stuff that-
Okay, everybody like,
Yeah,
"Rrr."
it was like 6,598 milliliters.
Okay, so it's gonna be 6.598 centimeters cubed.
6 point what?
Cubed. 6.598. So if we're going from micro to centimeter, typically how many places are we gonna move? One.
Micro to nano.
Milli to centimeter is 1, so 1, 2, right? And in this case, we moved 3, and that's because the 1 milliliter, that's one more place,
Yeah.
is the cubic centimeter. Most of this, you guys, I'm not gonna expect you to be math wizards on things, because everybody's at a different level math-wise. I have a straight up certified documented math disability. It's amazing I got through science, but I did. And when you start throwing numbers at me, I need the calculator.
That is keep in mind.
And that's
If you
cool.
grade this.
No. We're gonna practice them. That's all. When it comes to
Yeah.
labs and stuff, if you're comfortable doing it on your own, do it on your own. If you want, you use a calculator, use a calculator. But we're still gonna practice. We're gonna practice not using the calculator
Even if
too.
I know it, I always check.
I do too because I don't trust myself. So
Like, I'm like,
But I'm not the only one with that issue. I'm like, I feel my math is.
no, it's interesting because so like I was never great at math and I struggled with it a lot. And then when I got all the way to college to be in my major, they wanted me to take calculus. So I took it and I totally bombed it. And I had done okay with everything else, but I totally bombed it. And the problem was that it was a 6-credit class. So it took my GPA from like almost 4.0 to like 1.6 in a semester. It was terrifying because I was on full aid. So it was not something I wanted to do. So I go to my academic advisor and she was like, you ever been tested for a learning disability? And I'm like, no, I was in the gifted program. We wouldn't think about these things in the 80s. But yeah, there's like a 15-point gap between my IQ and my performance in math. So it's huge. It's bad. So that changed some stuff for me, but it also made me stop thinking I was an idiot too. So that's good. All right, how about 80,600 nanometers to millimeters? What do we have there? 0.0806
yeah.
millimeters. Do we have that one?
Yeah.
Yep. All right. 10.74 centimeters cubed to liters.
0.01. 0.0107.
Yes, it's 0.010741. So you got 1 0 after the decimal. Do we know how we got there?
Because you do 10.74
Mm-hmm.
or centimeters cubed equals
Right.
1 milliliter.
Mm-hmm.
So that's converted, and then you just have to divide by half.
Right, so if you're going from centi to the unit, 1, 2, which is what we did here, right? So that's 2. And then we ended up moving it how many times? 3, because we got that cubic unit in there. We're really not gonna do tons of it this year, so you really don't have to panic about it. All right, so then the next one, 7.93 liters to cubic centimeters.
7,930.
Yep, 7,930. Do we have that?
No.
7,900, yep.
So
There's one more dimension, so there's one more digit.
So that'll be 79,300.
7,930.
No, yeah, I have that.
Okay, because there's one more, when you think about one more dimension, you're adding one more dimension there, you're adding, whoops, I clicked too early. So how about the kind we're gonna practice in a minute, or the kind we're gonna do this year? We're not gonna do too many of these. So 0.0059 kilometers to centimeters.
590.
790, okay. 4.19 liters to cubic decimeters.
41.9.
There you go. All right, 44.19 decimeter cubed. 7.48 meters cubed to square centimeters.
74800.
74,800, right?
Yeah.
Centimeters squared, and then 0.197 meters cubed to liters.
Yeah, 197.
Yeah, 197 liters. Okay, so then you had a couple word problems. So if an automobile uses 0.05 milliliters of oil for each kilometer it's driven, how much oil in liters is consumed if an automobile drives 20,000 kilometers?
40 liters, right?
40 meters?
One,
Liters. is what it
1
is.
liter.
1 liter.
What?
1 liter,
Because it's 0.5 times 2, do which makes it 1,000,
right?
and 10,000 multiplied by 0.1, 10 multiplied by 0.1 equals 1 milliliter every 20 kilometers, and then 1,000 kilometers times 1 equals 1,000.
No,
Right.
Do you wanna- do you want to show that?
Get data.
Can you write that? Here,
How does it feel to get data?
go for it, Alex.
Called up to the big board.
Wow, you made some big moves.
Wow.
Erase them. All right, here we go. I'm gonna turn this around so you guys can see, because you can't see it's reversed this way. So. Where is he? Here he is. Okay, there. So,
Okay.
okay, good, there's Kai.
Jesus Christ.
Whoa.
I'm just gonna sit here and pretend I know.
Yeah.
Well, that's how you fake it till you make it.
He's the numbers guy. There's always a numbers guy. Michael likes numbers too.
Nerd.
Nerd. I'm gonna look at this.
Hi, Abby.
Hello.
All right, there we go.
Ivy, I love your backdrop.
Thank you. It fell over because I haven't been home. But big gaming over here.
All right, look at this. There we go.
Taking another picture.
All right, can you explain what you did? Okay.
Oh.
What
I
do we do?
multiplied 0.05 by 2 to get 0.1, and multiplied that by 10 to get 1, and multiplied that by 1,000.
Okay, so basically you kept a balanced ratio the whole way through, step by step. Yep. Okay. So awesome if this is your thing. If it's not your thing, no panicking. That's why I invented Ghostman. All right. So then, let me turn you back around. You're looking at Ethan's elbow. How many microliters are there in a volume of 370 millimeters of cobra venom? Yeah, 300 and, oh yeah, millimeters, sorry, I was moving the thing.
370,000.
Or 370 microliters. Yep, 370 microliters, yep. All right. And then a baker uses 1.5 teaspoons of vanilla extract in each cake. How much vanilla extract in liters, this is what us bakers do all the time, should the baker order to make 800 cupcakes?
60 years.
All right, so I gotta move this over because the answer's under there, under your faces. 6 liters is right. Okay. Person drinks 8 glasses of water a day, and each glass contains 300 milliliters. How many liters of water will that person consume in a year?
876 liters.
And then what it is, well, it's, yeah, wait a minute.
866.
Yeah, and then 876 kilograms of water. And, wait a minute, that's not right. I wrote something wrong down. No, it says 0.876 liters of water per year. That does not make sense. That's wrong.
But the question is kilogram.
Yeah, well, yes, but it's asking what's the mass of the volume, but this first part is not correct. Yeah, this isn't right. Ignore that right there. That's not good. Okay, so here's the ones we're gonna try our own. All right, so these are not the hard ones because these are the ones we're actually, these are the ones we're actually gonna use. All right, so what I'm gonna do is I'm gonna write a couple up here, and you guys can volunteer to do them. They are not the hard ones. These are the ones that are more common to what we'll be doing.
I don't know if it's a brownie point, but you gave the same Rico prompt for both.
I
Yes and no.
probably did. I probably did, man. I probably did. It gets.
And you can use you or am. Some people use a you, some people use am.
You gotta put a U in between the two D's.
No, you can use an am.
You know why? Because we used to say King Henry died Monday because they just let us say meter.
Yeah.
But I don't like that because it's not always meter, sometimes it's liter. But when I wrote it out, I inevitably, it's like when you're filling out a form and I ask for today's date and you put your birth year or whatever, you know. That's always fun. Okay. All right, so here's what we're gonna do.
I wonder how you would do like Graham for like if King Henry died Monday, King Henry
Yeah.
died
Great.
great.
Yep. All right, let's do.
Really
will
drinking
die.
chocolate.
Yep, Ella Felicia will die too.
Can I say El Felicia?
El Felicia.
Felicia, you know, she has some hard times with us.
Yeah, hard times, just, I mean,
That's supposed to be 6
Liters, yeah, that's why it gets like that.
because it also looks like 61.
Yeah. You know, I'll make it
Yes,
nice.
that's why they have
That is why they capitalize
Yeah.
it, but it makes me nuts because it's just, it's not, that's one that's not always consistent.
It's consistent when it's needed.
Yeah. And lastly, much more along the lines of the level we'll be doing. Okay, all the crazy may come in and allowed every now and then, and it might show up, but it's not gonna be consistently something we're dealing with. Okay, would anybody like to do 1 or 2 or 3? Pick a color, and I'm gonna spin this around. All right, if you want to do one, grab a pen, go up and do one. Okay. I'm gonna, whoop, sorry, turn this around. Make sure you can see the board.
I assume it's milliliters, right? Is it now?
Yeah,
Yeah.
there's no microphone here. Where did it go? There's the board. That's the board. Sorry, I'm trying to get the
I
whole
was,
board.
I was wondering if it was micro or nano.
It's just from your angle, like, is it, you put it on your book or whatever? Is it far enough back? Can you
I
just
think
back
you
up?
switched. You made vanilla.
2000.
You
Wait,
made
did you have to
you
go
made,
right?
you made mega lowercase and micro.
Did you get
Right.
There
there?
you go, that is here.
Okay. Well,
No
then
matter.
why is your M next to K lowercase and then your 9,000 K mega lowercase? Look, you made the
Lowercase.
mega on the top a lowercase.
Well, I don't know,
So
I'm
that would make
sloppy,
you
my
sense.
handwriting's bad.
She's
It
trying
would
her
make sense that
hardest.
and then the other one is also.
This one?
No, that's a U.
I'm not one of these people that does these crazy, these are all lowercase and ones.
She is trying.
There's no one done that.
Or
Here, let me scooch around.
Actually, can I get orange?
Sure. Pick a color. Can they see Abby?
I think so.
Okay.
You cannot send those colors.
No, it's not my favorite. It's me, Abby.
This is Millie.
They're all lowercase, no milling. Yeah.
Wait, wow, just do the one on the side. Great, thanks.
Wait,
Stop it.
90 or 96?
That's 90.
Hey, tell them Mom I did it after process. Good enough.
Good. We got 2 more on this side. Who wants to do the 2 more on this side? Come on, Bailey, go ahead.
I guess
Stop,
I'm not.
Alex is going
I
to.
didn't want to stick it together. Oh, okay. There you go.
Alex needs to, he's trying to restrain himself, but he just wants to answer them all.
Sorry, I just couldn't buy everything. Thanks, Kate.
Oh, thank you.
You can do it. Answer the question.
Only one more.
Yeah. Well, oh.
Genius at work.
We good?
Genius.
Thank you. Thank you.
I did more.
Sound
I'm
like
gonna
a
take a picture of
bird.
it.
Show you another bit. You did math?
Oh, I did
Sort of give
well.
this back to you.
Oh, yeah, that's, that's okay. Now you're like, for sure, like, weird. Right? There's the rest of your class right there.
So I did
Yoda.
5
All right.
No science.
Does everybody agree with this answer? 2,000 meters is 2 kilometers. Do we agree?
Yeah.
Yeah, good. Oh, that's not supposed to be a 2,000 meters. Yeah, that's bizarre. I have another. Ignore this dot. I cannot type, you guys. Like my whole PowerPoint is messed up.
There's a chance that somebody could, if you do this via Zoom, one person might be able to draw. Might be able to draw on.
I gotta fix that one. Okay, I'll fix that. I'll fix it before I save it in your notes. All right, 9,000 milliliters is how many liters?
9.
Here we go. Good. And 6 liters is how many milliliters? Whoops, I went the other way. Yeah, hang on. I went the wrong way. 9 kilometers is how many meters?
9,000.
9,000. 3 kilograms is, I have to keep moving their faces. How many grams? 3,000, good, okay. 90 millimeters is how many centimeters?
9.
There you go. And 6 centimeters is how many millimeters?
60.
60. Right? Oh,
See, I'm just,
wherever it is. Where'd it go? There it is.
left center.
Sorry, yep. And then 4 kilometers is how many meters?
4,000.
4,000. Okay, good. I gotta fix that. Not supposed to be about there. All right, and then that's about that for this lesson. So for your next lesson, we're moving into.
How many people colored Rico?
Did anybody color Rico? Okay, they colored
I
Rico.
don't
Good.
have-
All right,
I
if
don't
you
have time.
colored a Rico, let me see who you've got. Let me see these Ricos.
All right. Done one the first week.
I wanna see if
Then our
anybody has this.
balance would have been on my
All right, I'm gonna take pictures of them because I might have 3 more coming in. Let me see. Hold on.
I should have done one the very first.
Okay,
week.
those are good.
Artistic talents would have been unrivaled. No one else would have been.
No one else in the room. All right, so looking ahead, all right, you're gonna make sure that you have today's lab complete in your binder, right? Right. You with me? Are y'all with me? Michael, Cole, your chitty chatty. All right, and then if you were gone, you're gonna get that information either from your lab team or from the video. Probably easiest just to get the information from the video, okay? Great, so this next week, we're gonna be starting Unit 2, Chapter 2. So this is matter and energy. We're still in, so the unit we're in is the same one we were in. This is the Introduction to Matter and Chemistry. So you're going to be going over energy, studying matter and energy, measurements and calculations in chemistry. There's not too much more math before we get into nitty-gritty. Chemistry is more math heavy than the other sciences, for sure. So you're going to read sections 1, 2, and 3 in your textbook, and then your homework is in your binder. And what does it say for your homework?
What does it say?
What does it say? What does it say to do with your homework?
Turn in.
Turn in.
Next week.
So if you look at your homework, it's this sheet right here, right? So this is what you turn in for lesson 3. You with me? Or did you lose? Did you get lost? Did I lose you? Okay. All right. Next week's lab, you should always look ahead to the lab, right? Next week's lab, I just grabbed, hang on, that was the junior's homework. That's not your homework. Your homework is, you did?
Yeah,
Where?
in the first one of the homework, it says name two types of things. And it's not, it's TO, not TW.
Oh, let me see. Where is it?
Wait,
where is it? Tell me.
The first question of that homework.
First question in the homework. I just showed you guys the junior's homework too, so hold on. Oh, here it is. Oh, yes. You're looking at this?
No.
What are you looking at?
This?
You're looking at the weekly notes, so, but not the turn-in part, but you're looking at,
Homework assignment, turn in.
okay, hang on. I want to make sure I'm following you.
Lesson 3.
Lesson 3.
View 8.
Did I skip? I know, I'm wondering if I skipped a page in here because I'm flipping. There's 4. There's you.
Lesson 3.
Yeah, good, I'm looking.
Yeah.
Yeah, that's that.
That's not what we
That's
have.
not what you just looked at, so, what up?
It's
Let's see.
lesson 3, page 7. It's the weekly homework assignment.
Okay, so what you're looking at then is this worksheet? This one?
No,
No.
What's this page over? I
that's,
want to make sure I'm looking at what you're looking at.
That's what
This one?
no. That's not it.
Hey, what are you all looking at?
This is what we're-
Hey, hold on, I'm gonna make sure that you're.
What are you doing?
Just the Rico
What is
page.
it?
It should be after, it should be right around the Rico.
Hold on.
Reek?
I may have, it should be Rico, but I'm wondering if I flipped. I may have just
The
flipped.
one you
to
showed
her.
to us that
That's
was
4, I think.
junior looked like.
Yeah.
You colored your Rico?
3.
That's awesome.
Bro, like
I
I
like the line.
Those gray highlights are just great.
What matters to Rico
Wait,
is.
oh,
the
my
way you
binder's
look at it,
missing
very
your whole
abstract.
3.
Abstract.
Oh, that's fine. It's probably I'm sure it's in my file though.
But yeah, that's 4 brownie points for us.
Tell me where, I wanna know where
But she
it is.
doesn't prove that she doesn't have it.
There's
Wait a minute,
So-
no, you know why? Because the dude who made my copies did not get my copies correct.
Like, we could watch.
They were
about the guy
a
from Office.
mess. They were a huge mess.
Send you a little bit.
Okay, I see where you are. Yep, it's right here. All right, correct. So that's your 4th brownie point today?
I know you.
Yeah.
Okay, good. Yeah, it's in here. It's just, it didn't make it into that, you know.
So we're at 4 points already.
Yep, but my sister knows things. So,
Yay.
all right, let me stop doing that.
Kai, write
Okay.
that down, write that down.
No.
Yeah, Kai, write that down. Write that down, sorry. I don't know what I'm talking
It's
about.
frustrating because I give them all this stuff and then they give it back to me and it's this, sometimes it's a jumble and this time it was like a half. So
Yeah,
it was a little messy.
What?
I think people at Office Depot have just stopped caring. They're like, they're like, oh, you need this copy, okay.
They're good
Just
people.
throw it on the machine.
It's a lot of, I throw a lot of work their way. I'm not gonna blame them for stuff. Wait, no, here it is. It's just like in the wrong section. I don't know why, but it's in the wrong section.
There's one guy that
I
looks
think
at
they did what your teacher did with the fire thing, because throw it on the copy machine and hold it.
Highly likely.
I'm not.
All right, so
Yeah, can't vote.
does anyone have, Cole, you guys have to hush. Does anyone have any questions about next week's work, next week's lab, or anything like that? Does anybody have any questions about this week's work? For those of you that are at home, I mean, really all I need you to, where are you? There you are. I lost you for a second. All I need you to do is just, you know, send me a PDF of what you have so I can see that you got it. With homework, so that you know. With homework,
Yeah.
I don't grade what's wrong because I expect you to still be learning it. I just want to see that you've done it. With tests, it's what's wrong. Kai, you got a question?
Yeah, I'm gonna try to send you all the homework I have today.
Yeah.
I have worse internet connection in Clarksville,
Mm.
and it was terrible. So, but I'll try to send it all today. But like, oh my god, it was awful. Everything's awful, but it's
I'm
okay.
teasing you. I just want you to know
Yeah.
that right now. Like,
Oh no, yeah, you've been texting me your whole class, disrespecting me.
You're
there it is.
disrespecting yourself. I didn't say anything, Kai, for the record.
I think
You're still in the text messages?
Huh?
I'm gonna kill you.
I think it's just Ethan.
you guys are the best.
Oh, wait.
Okay, that's fun. All right. She's like, what?
If that's on YouTube.
All right, so you guys have about 10-15 minutes before Miss Jackie starts. I would suggest if you didn't finish the lab, that you take the time now, right now. Don't go wandering. Take the time now, right now to get that done. Like spend a minute looking. If you didn't get to the data, borrow somebody else's. If you're at home, watch the video, it's out. Write down the info. Are we all good?
Is Drew able to be grabbed?
Yeah, probably. No, not right now. He's wrapping up class.
Ozzy.
So for everybody online, tell everybody online, go bye.
Ah.
Bye, guys. See y'all later.
Bye, Kylie.
Bye. I gotta
Ozzy
fix
started